Hi and welcome to this lesson where we will look at mass and moles, and we will see how can I work out mass if I'm given moles, or how can I work out moles if I'm given mass. Okay, so just to recap quickly, in the last lesson we looked at molecular mass, and that is going to be the capital M. So this can either be molecular mass or it can be atomic mass. Okay, so atomic mass if I'm working with a single element that is just an atom in its substance, or molecular mass is if I'm working with a compound like H2O. Okay, then lowercase m will just represent the actual mass that I'm working with. Okay, the actual mass that I'm working with. And if my actual mass is equal to the molecular mass or the atomic mass, it means I have 1 mole. So N will represent the number of moles. Number of moles. If my actual mass is double the atomic mass or the molecular mass, it means I have 2 moles. So that the relationship is that the number of moles is equal to actual mass divided by molecular mass. So if actual mass is bigger than molecular mass, I will have more than 1 mole. If actual mass is less than molecular mass, I will have less than 1 mole. Okay, so let's look at a few examples. Okay. What is the mass of 2.5 moles of carbon dioxide? Okay, what is the mass of 2.5 moles of carbon dioxide? So I'm trying to calculate lowercase m. Capital M is actually a constant for any given substance. So carbon dioxide's capital M, his molecular mass, is a constant for this substance. So it's not always the same value. It's always the same value for a specific substance like carbon dioxide. So that is the first thing I'm going to work out, is the molecular mass for carbon dioxide. Carbon consists of 1 carbon, so I'm going to get carbon's molecular mass here, as atomic mass I mean, plus 2 oxygens. So I'll put 2 oxygens atomic mass in there. I need my periodic table. If I go to my periodic table, I see I've got carbon has a atomic mass of 12 and oxygen has an atomic mass of 16. So I've got 1 times carbon's 12 and 2 times oxygen's 16. This gives me 1 times 12 is 12, 2 times 16 is 32. Together this gives me 44 grams. Okay, so this is the molecular mass for carbon dioxide. Now if I had to calculate the mass that 2.5 moles will have, that's lowercase m. Okay, and all I'll need to do is substitute into this formula. I've got 2.5 moles is equal to how much mass divided by the 44. So I want to know what mass must I have so that if I divide it by 44 I will have 2.5 moles. Obviously I need more than 44. I need double 44 and more, okay, because it's even more than double. So if I solve it, it just means I multiply 44 on both sides, and that gives me 44 times 2.5 is 110. Okay, 110 grams. In other words, if I have 110 grams of carbon dioxide, I have 2.5 moles of carbon dioxide. What does 2.5 moles mean? Well, remember, 1 mole is a number of atoms or a number of molecules. Not 6 times, it's 6,0221417 times 10 to the power of 23. So this is a number of molecules. I have 2.5 times this number of molecules of CO2 in 110 grams of CO2, carbon dioxide. I hope that makes sense. Let's look at another example. Let's say how much mole, suppose it's how many moles. How many moles of H2O is in 1 liter? Okay, so how many molecules of H2O is in 1 liter? Okay, now I don't know if you know, but 1 liter of water is 1 kilogram. 1 kilogram, we are working in grams, is 1,000 grams. So we're basically asking how many moles of H2O is in 100 grams of H2O. Okay, so again we start by calculating the molecular mass of H2O. Okay, that is 2 hydrogens. Hydrogen, if we go to our periodic table, you'll recall has an atomic mass of 1. Okay, that's approximated. Plus oxygen, there's 2 of them, so remember 2 plus oxygen is atomic mass of 16. I only have 1 oxygen, so this has a total atomic mass of 18. Okay, so total atomic mass of 18. So let's substitute into our formula. N is moles is mass over atomic or molecular mass. Okay, N is what I'm trying to calculate. Mass is 1,000. Okay, I've got 1,000 grams, but for every 18 grams I have 1 mole. So how many times does 18 go into 1,000? That's the calculation. And if I do it, that's 1,000 divided by 18 gives me 55.56 if I round to 2 decimal places. 55.56, okay, mole. Okay, that is the unit that we will use for mole, M-O-L, okay, but if we were to write it out, it will be moles. But remember to write out MOL at the end of a question asking you for mole. Okay, that's really it. It's not very difficult. I hope you understood. Just a quick recap that we can use this formula. N is equal to the number of moles is equal to actual mass divided by molecular mass. In the question, you will always have to go and find molecular mass using your periodic table. Okay, and then either the number of moles or the amount of a substance, the mass of a substance is given, and you must work out the other one. Well, I hope you enjoyed this video and that you learned something. I'll see you in the next video.